Okay, this is the review for fractions, grade 8 fraction review before your final exam. And question 1 is a true-false question. It says 2/5 times 3/4 is greater than 2/5 plus 3/4. And 94% of you said false, which is the correct answer, and here's why. If you take this part right here, 2/5 times 3/4, one of the things that's true about all products, meaning multiplication of two fractions, is that when you multiply two fractions together that are just regular fractions, not improper fractions or mixed fractions, but two regular fractions together, you will always get an answer that is less than 1. Always. Okay? And the only way we could show why that's true is when we model it. And most of you forget modeling, but I'm going to show you that this really, the intention of this product is really to show 2/5 of 3/4, right? 2/5 of 3/4. And there is no way, when you have 2/5 of 3/4, if you think about this as a model, when you have a fraction, in this case 3/4, and you want to take 2/5 of that, no matter what fraction this is, when you take a fraction of a fraction, you can never have more than 1. In this case, if I put fifths, 2/5 would look like this. My denominator would be 20. This picture would represent 6/20, which in lowest terms is 3/10, which is less than 1. When you have the product of two fractions, your answer will always be less than the second fraction, right? Always be less than the second fraction. So for this one, because this number is less than 1, I don't have to actually figure out what it is. I know that when I multiply this together, I already solved it, but if I didn't solve it, I know my answer would be less than 1. And a number that's less than 1 can't be greater than this product if this is greater than 1. So when I add these two together, you need common denominators when adding. 8/20 and 2/5 are equivalent. 15/20 and 3/4 are equivalent. I have 23/20, which I don't have to change back anymore because I know that is greater than 1. So something that's less than 1 cannot be greater than something that's greater than 1, so therefore it's false. That's the logic that needs to go into these types of questions. I know there's a lot for that last one, but anyway. Question 2 says 1 4/5 take away 3/4 is less than 1 4/5 times 1/4. So for this one, I'm just going to use estimations. Now, if I think about this as money, this question would be $1.80 take away 75 cents, right? So without working out the answer, I don't care what the answer is. I know that the answer is going to be what? Greater than 1. So all I'm going to put down here is greater than 1. I'm going to do this. So greater than 1 is less than whatever the product is. So I'm going to actually work out this part of it. So 1 4/5 times 1/4. A whole bunch of different ways you can do it. The easiest way is to change this to mixed, which is 9/5 times 1/4, which would be 9/20, which as an answer is less than 1. So is something that's greater than 1 going to be less than something that's less than 1? No. So the answer is false. Now, if you actually worked out this question here, you would have 9/5 take away 3/4, which is common denominator, multiplied by 4. Multiplied by 4 is 36/20 take away 15/20, which is 21/20, which is 1 1/20. So yeah, this one is not greater, so it's false. Question 3, oh, we had a 50-50 split on the answer for this one. This is a great one. The last class, I think 23% had it right in the other class. So this one really is a good, tricky question. So it says a recipe calls for 5/8 of a cup of butter. Okay? If you have 2 cups of butter, you could triple the recipe. So let's look at this. From a drawing standpoint, I have 1/8, I have 2/8, I have 3/8, 4/8. This is the amount of butter that's required for the recipe. If I triple the recipe, I would take this and I would actually, oh, no, error. That's interesting. If I tripled this, not, oh, for God's sake. If I tripled this, infinite cloner. So this is what's needed for one recipe. That's 2 recipes. That's the amount of butter I would need if I was to triple the recipe, because 5/8 is what you need for the recipe. I'm going to triple it. So that's how many eighths I would need. So really, I'm taking 5/8 and I'm timesing it by 3. And what this is the requirement of how much butter my recipe would require if I tripled the recipe. Think of it as being over 1. I would require 15/8, which is 1 7/8. If I was to triple a recipe, I would need 1 7/8 cups of butter to triple the recipe. I have 2 cups of butter. So because I need this and I have this, I would have enough butter to triple the recipe. So the answer is true. You could triple the recipe because you need 1 7/8, which is less than 2 cups. And since you have 2 cups, you can triple the recipe and have 1/8 of a cup left over to butter your muffins or pancakes or whatever you're making. Question 4 is a statement that says 2/5 divided by 4 is equal to 1/5 times 2/5, 1/4 times 2/5. So if we look at this first one can really be thought of as this. And the second one, if I was to really think about what this was, 2/5 multiplied by the reciprocal, using division of fractions, I know that this is true. And if I really look at this second one, all I've really done is I've changed the order of my 2 fractions. So because the order in which you multiply 2 fractions together doesn't affect the product, I could switch them and it would be true. So the answer is true. They are the same product. Question 5 stumped 18% of the class, or more than that, 25% of the class. Shouldn't have, because 3 times 4 and 5 times 9 gives you 12 out of 45, which some of you, 18% of you, thought was lowest terms. But if you know your divisibility rules, 1 plus 2 equals 3, 4 plus 5 equals 9. Both of these numbers are divisible by 3, which means both of these are divisible by 3. In lowest terms, it's 4/15. Some people might have taken this and they remember that when you multiply 2 fractions together, it is possible to cross-reduce before you do your product. And in this case, you would have got 4/15 right away without having to reduce it here. Question 6. Oh my gosh, what happened here? What happened? Oh, okay, I just put it in the remote wrong. So 87% of you got it right. When multiplying these two, when you multiply by a whole number, it's easiest to think of the whole number as being over 1. Therefore, the algorithm, if you will, of multiplying numerators together and multiplying denominators would be 12/5, which is 2 and 2/5, which is your answer. Question 7, all of you got it right except for maybe one person or 2 people. A half multiplied by, if you have a mixed fraction, it's easiest to change that mixed fraction to improper, would be 11/4. Multiply your numerators, multiply your denominators, you get 11/8, which is 1 and 3/8. Question 8, 75% of you got it right, which is interesting because it's not that hard a question. So 3 1/3 as an improper fraction is 10/3. Multiplied by 5, think of the whole number as being over 1. Multiply your numerators, multiply your denominators, you get 50/3. This is where the tricky part is. 3 times 18. Did I make a mistake there? Sorry, 3 times 16, excuse me. 3 times 16 is 48, which means you have just enough to make 16 whole numbers with 2 left over. So your final answer is 16 2/3. Question 9. Ooh, wow. A lot of people got it wrong. Only 64% got the correct answer, I think. Question 9. 1 and 5/6 as an improper fraction is 11/6. Multiplied by 1 and 2/3 as an improper fraction is 5/3. Is it possible to cross reduce here? Is it possible to cross reduce here? Is it possible? Hello, Bueller? No, it's not. You get 55 over 18, which is 3, because 18 times 3 is 54. Since you have 55 eighteenths, that means you have 1/18 left over. So 55 eighteenths is equivalent to 3 and 1/18. Question 10 is division. So 5/8 divided by 3 is the same thing. It's the same answer. It's not the same thing. It's the same value as 5/8 multiplied by the reciprocal of 3. They have the same value. You get 5 out of 24 as your final answer. Question 11 is a similar question to the last one. So 3/4 divided by 1/3 is the same value as 3/4 multiplied by the reciprocal. The reciprocal of 1/3 is 3. Multiply your numerators, you get 9. Multiply your denominators, you get 4, which is 2 and 1/4 in lowest terms. Everybody got that one right. Oh my gosh. 61% got this one right. So first step in division of mixed fractions, the easiest thing to do is convert them to improper. So this is the same question. Keep your first fraction, change to multiplication and use the reciprocal, has the same value as the division question. If you wanted to, you could cross reduce right now. 2 over 4, if you had 2 over 4, would reduce down to 1 over 2. So this will become a 1. This will become a 2. You get 13/10, which is 1 and 3/10. If you didn't cross reduce, you would have got 26/20, which is 1 and 6/20, which is 1 and 3/10. Either way, you get the same answer, 1 and 3/10. Question 13. A quarter of the class got 2 and 1/5. Let's see what happened here. So 2 and 1/8 is 17/8 divided by 5/8, which has the same value as 17/8 multiplied by the reciprocal. What makes this question so nice is the fact that if you know how to cross reduce 8 over 8, if 8 was over 8, that would reduce down to 1 over 1, which leaves you with just 17 over 5, which is 2 and 2/5. Sorry, 3 and 2/5. If you didn't cross reduce, you ended up with a messy looking thing that would be 80, what's 80 and 56? 136 over 40, which is 3 and 16/40, which reduces down still to 3 and 2/5. Most of us got this right, which is good. Order of operations, don't do your addition until your multiplication is done. That would be 9/16. Once you have that first step done, you're adding, which requires common denominators. 4/16 plus 9/16 is 13/16, which is lowest terms and is your answer. Unga bunga. Wow. 46% got this one right. What happened here? Well, let's look. So when you're dealing with the product or addition or subtraction of any fractions, it's always easy to convert them to improper to start. So I'm just going to rewrite this question. Not doing any operations, just changing the mixed fractions that I have into improper. The next thing I have to do is realize that I'm not going to subtract yet. I'm going to find out what the product of these two is. That's going to be 5/6. 1 times 5 is 5. 2 times 3 is 6. Once I have it written like that, I need a common denominator. 6 will work nicely. The equivalent fraction to 8/3 that has a denominator of 6 is 16/6. 16/6 take away 5/6 is 11/6, which is 1 and 5/6. Thank you. Does anyone want to articulate what you did wrong there? Because like over half the class had the wrong answers. Anyone? 1 and 5/12. Who had the wrong answer and doesn't know what they did wrong? Okay, watch that video again then, and just watch that question in slow motion, and maybe it'll make sense. Probably not. Question 16 is a modeling question. For 16, 17, 18, and 19, a lot of you have forgotten how to model, so keep in mind that if you're doing a retest on fractions, the modeling format will not be different on your retest, so just pay attention to these, and the procedure will be the same. So you have a half, and if you multiply it by 3, all you're doing is tripling it. So 1, 2, 3. That's what the model looks like for 1/2 times 3. And when you think about what that means, how many halves do you have? How many halves do you have when you triple a half? You have 3 halves, which is an improper fraction. When you reinterpret that, you could think, well, what if I put this half here? Then I would have 1 and a half left over. Okay? So visually interpreting what that means, you would have 3 halves or 1 1/2 in total. Question 17 is a half times 3/4. The first step you need to do is think of it as being a half of 3/4. The intended purpose of multiplying two fractions together is to get a fraction of a fraction. Right, Colin? Somebody nudge him, make sure he's alive. Okay, good, he's alive. So a half of 3/4 would be when we use it, where we're finding a fraction of a fraction. And if we think about visually what that looks like, if I had half of 3/4, I would have to start with 3/4 and take half of that. So half of 3/4 would be that much right here, which is 3/8. Question 18, a half times 1 3/4. Anytime you're modeling a mixed fraction, you have to have an area model. So a half would be the length of this particular part of my rectangle. 1 3/4, this distance here would be 1. This distance here would be 3/4. So a half times 1 3/4 would actually be the sum of a half times 1, which is the area of this square or rectangle, plus this one, which would be a half times 3/4. A half times 1, anything times 1 is itself, so we have a half here. Over here we have 3/8 for the product of these two. So the whole area, meaning the product of a half times 1 3/4, would be a half plus 3/8, common denominator. 4/8 plus 3/8 equals 7/8, which is your answer. Right? And finally, question 19. For everybody, I made a mistake when I made the test. I meant the question to be 2 1/4 times 1 3/5, but I just put 3/5. So press pause on the video. Try this question instead, and then I'll show you what the answer is. So everybody, try this one right now. Okay, so now that you've done it, here's what you should have drawn. First thing you should have drawn is an area model that looks something like this. So this distance here, oh, hang on. Oh, that's less than exciting. I'm going to go back. So not what I wanted. So this distance here is 2 units. This is a quarter. This distance here is 1, and this distance here is 3/5. So when you take 2 1/4 multiplied by 1 3/5, if I was to just kind of chop up an area of a rectangle, we know that the whole rectangle, the area of this whole rectangle, would be the product of 2 1/4 times 1 3/5. But what we're really doing with the area model is we're breaking up into 4 parts. This part will be 2 times 1. This part will be 2 times 3/5. This part will be 1/4 times 1. And this part here will be 1/4 times 3/5. So if we break it up into 4 smaller groups and add them together, that will be the same answer as 2 1/4 times 1 3/5. So this one's easy. That's going to be 2. And this one's easy because it's going to be 1/4, because anything times 1 is itself. So right off the bat, I got half of my area model done. Now this one here, 2 times 3/5, think of 2 as being over 1, and think of it as being that. I'm actually going to get 6/5 of my answer, or 1 and 1/5. So this answer is 1 and 1/5. Now I got 3 of my parts done. And the fourth part is the product of these two. 1/4 times 3/5 is going to be 3/20. So now I have all 4 areas. And if I add them up, that's going to be the same answer as if I multiply 2 1/4 by 1 3/5. So 2 plus 1 1/5 plus 1/4 plus 3/20. The sum of those 4 numbers will be the answer. So right off the bat, I'm going to get rid of my whole numbers. I'm going to go 1 and 2, and I'm going to put that 3 over here. So now what I'm going to focus on is just the fractional parts of the answer. Use 20 as my common denominator. The third fraction won't change because 3/20 is equal to 3/20. 1/4 is equivalent to 5/20, and 1/5 is equivalent to 4/20. Now that I have common denominators, add my numerators. 4 plus 5 plus 3 is 12. So my answer, if I bring this over here, if I take this and bring it over to my 3, an acceptable answer is 3 and 12/20. That is the correct answer. However, in lowest terms, both are divisible by 4, which means my final answer should be 3 and 3/5. How many got that? How many got 3 and 3/5? How many didn't but realize where they messed up? How many have no idea what they did wrong? Okay. For those of you who got it wrong and have no idea what you did wrong, watch the video again in slow motion or in double speed or in Google Translate and do a language of your choice, and hopefully it'll make sense. Remember that on your retest, if you are retesting this chapter, question 19 on your retest will be a mixed fraction here, so be aware that you must be able to model just like you did in this picture. Okay?